Welcome to Unit 3, and it's on trigonometry, one of the most important units we cover here in the geometry second semester. In video 3A, we're going to talk about the trigonometric ratios, and you've already had this but let's see if we can make it stick here. First of all, ratios are fractions. Trigonometric means triangle measures. And what the trigonometric ratios are is they are the ratios, fractions, of the sides of right triangles. And we give those ratios names. Now off on the side here, I don't want you necessarily to draw this to take a look. I'm going to draw a special right triangle from the last section, the 45, 45, 90. Just watch this. We said that because it's half a square, the sides are always the same length. And let's suppose I make this one 3, then this one's 3, and this one's 3. Whoopsie, sorry. This one's 3 times the square root of 2, and we covered that in the last section. Now I'm going to make a bigger 45, 45, 90 triangle. So I'm going to keep those angles still the same measure. But now I'm going to make the sides 5 and 5, because again, the legs are the same, and the hypotenuse would then be 5 times the square root of 2. And I want you to watch what happens when I look at the ratios of some of the side lengths. Let's talk about the legs. This leg over this leg would be 5 over 5, which is 1. Well, even on the shorter triangle, when I do that same ratio of leg to leg, I get 3 over 3, which is 1. And the ratios of the sides are the same regardless. I could have made a 18 gazillion by 18 gazillion 45, 45, 90 triangle, but when I do leg over leg, that ratio, I'll still get something over itself, or 1. Watch me do another ratio of sides. Suppose I were to take this one, which is 3, over this one, which is 3 root 2. You'll notice the 3's will cancel, and I'll get 1 over root 2. Well, it doesn't matter if the sides are longer. When I grab that same ratio, I would get 5 over 5 root 2, and the 5's would cancel, and it really doesn't matter what lengths I made those sides. The ratios stay intact. And we give those ratios names. And that's what the trigonometric ratios are. And there are 3 main ones. 3 main, and then there's 3 others that we're not going to talk about due to time constraints. 3 trigonometric ratios. And then before I put them on there, I'm going to have you draw just a generic right triangle. And again, this is only for right triangles. We're going to put angle A right here. We're going to classify all these side lengths. I know that you know that they're leg, leg, and hypotenuse, but we're going to classify them with respect to the angle that I'm staring at. And I'm staring at angle A. And this is still called the hypotenuse, locked and loaded. But the legs get more refined names. We call the leg across from the angle in question the opposite leg. We call the one right next to it the adjacent leg. So we're going to be a little bit more specific on how we classify these. And then we have 3 ratios that we're going to identify. We are going to call the sine of angle A the ratio of its opposite side to the hypotenuse. And it's just a name. Sometimes it bugs kids. They're like, I don't get what sine is. It's just a name. Like, why is the thing on your foot called your shoe? The sine of the angle is the name given to just putting this opposite side over the hypotenuse. And no matter how much bigger I make that, as long as I have those same angle measures. Again, I just showed you that those sides are all proportional. So what I get is an abbreviation that I say A over H. So sine of an angle is its opposite side put over its hypotenuse side length. The cosine, which we abbreviate as cos, but it's actually cosine of angle A, is when we grab the adjacent side and write it as a ratio with the hypotenuse. So we call the cosine of an angle its adjacent side over its hypotenuse. Again, it's just a ratio, and we can make it a decimal if we want. The third one is the tangent of an angle A. And that's the name we give to the opposite side length over the adjacent side length. And we call that O over A. Then we have a little mnemonic that helps us remember those. It's called SOHCAHTOA, which I'm sure you've heard about. And I like to write it like this: So, ka, toa. So I can see them as ratios. Maybe you've seen it written like this, which is fine. I like it though with the fractions in there, so you can keep in mind that these are fractions. So sine of an angle is its opposite over its hypotenuse. Cosine of an angle is the ratio of the adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. Now, remember when I drew, just so you can, I just want to make sure you understand the concept of these before we go and do this. Remember when I drew the 45-45 a little while ago and I put a 3 here and a 3 here, and I said, you know, if I were to do leg over leg, I get 1. Well, watch. This is 45, right? This is opposite. This is adjacent. So what I'm telling you is that the tangent of a 45-degree angle is its opposite side over its adjacent side, which is 1. What does that mean? It means for any 45-degree angle in a right triangle, that ratio will always hold. Now, the calculator is helpful in this situation, so you should stop, get a graphing calculator if you don't have one. So pause the video, go get one. What we're going to do now is hit your mode button. They are defaulted to what's called radian mode, and we're going to work with degrees. So if you could right arrow over there and hit enter and be in degree mode, and then just hit second, quit. And if you missed that, that's the beauty of video. You can just rewind it. You'll notice these trig functions are on your calculator right here. We have sine, cosine, tangent. I just told you that the tangent of a 45-degree angle's got to be 1 based on its definition there. Let's go take a look. Tan. Go ahead and hit it. Whoop, I have some writing on there I have to clear out. So let me delete that. All right, so if I do tangent 45 and hit enter, look at what I get, 1. Just as I did by setting up the ratios over here. So we're going to use our calculators a little bit more later. For now, I'm going to move it off to the side, and we're going to continue with some trig ratio setups. So this one says, find the value of tangent z. All right, so I go to z and I like to put a dot in it. So I know that's where my eyes are going. That's how I classify the sides. So this is the hypotenuse, always across from the right angle. This would be classified as opposite. Right next door would be adjacent. I'm being asked to do the tangent ratio. But I'm circling it. The tangent of angle z will be the ratio of its opposite side to its adjacent side. I just need to go grab them. What is opposite angle z? 21. And what side is adjacent to angle z? 28. I don't know its measure, so I can't go to the calculator to figure it out, but I do know that tangent of it is, if I divide both of these by 7, just to knock it down a little bit, 3 over 4. So I'd say the tangent of angle z is 3 over 4. Now suppose I said, what's the sine of angle x? Well, that changes things drastically because now I have to erase all these classifications. I know it wasn't asked, but I'm going to show you. Now I put a big dot over here. Let's say I said X and I wrote A, silly. All right, suppose I was asked for the ratio for sine of angle X. Well, then I put my big dot here. And sine, again, is opposite over hypotenuse. So with regards to angle X, because that's what I'm looking at, I go opposite angle X over the hypotenuse of the triangle, which is 35. So you'll notice that changed quite a bit, and then I'd reduce the fraction. So let's move on to the next one here. Scroll down. I am being asked for sine of angle C. Well, my eyes need to go right in here at angle C. Sine is opposite, so opposite over hypotenuse. I had opposite, I'll write sine C equals. I had opposite for a 28. I go to the hypotenuse across from the right angle for a 35. I reduce that. 7 goes in here 4 times. 7 goes in here 5 times. And I say the sine of angle C is 4/5. Let's do tangent of A. All right, tangent of A, TOA, SOHCAHTOA, would be opposite angle A over adjacent. You might say, well, both of these are adjacent. They are, but the hypotenuse gets first dibs. So the side across from the right angle always has to be called the hypotenuse. And then I would reduce that fraction. So let's move on and see what we've got going here next. Cosine. Why don't you pause the video and see if you can set that ratio up correctly and then hit play and see if you did it right. For cosine, again, I think so. Ka, toa. It said cosine, so I grabbed that one. I go to the angle that I'm supposed to stare at and I put a big dot in it. I do adjacent. There are 2 touching it, but this one's locked and loaded as the hypotenuse. So my cosine of angle A is its adjacent side, which would be 30, over its hypotenuse, which is 34. And I could divide both of those by 2, giving me 10/17. And we can just leave it as a ratio. So next up in this video, this is kind of a long one because this is a very important section. The inverse trig ratios. You'll notice on my calculator, I'm going to bring it back into the viewing window here. You'll notice that above sine, cosine, and tangent buttons, you see that little sine with a -1, cosine with a -1, tangent with a -1. Those are the inverse trig functions. And what they do is they allow us to find the angle measures when we know the trig ratio. So watch. And I'm going to use numbers here instead of variables just to make it easier. Suppose I know that the sine of some angle was 1/2. I'm sorry. Let's give the, I was talking here. Sine of some angle, let's say A, let's suppose that equaled 1/2. What I'm telling you then is that I know the ratio of the opposite side to the hypotenuse is 1/2. And the question becomes, what is the angle measure? What I do is I use the inverse key. And I say, well then, to get that angle A's measure, I can do sine inverse 1/2. And my calculator will tell me what the angle measure is. Watch, back in, bring your calculator out, and go second sine, because I want to know the angle, 0.5, or you can even enter 1/2. And your calculator will tell you what angle has that trig ratio. And you'll notice when I hit enter here, I get 30 or 30 degrees. So then I would say angle A is 30 degrees. Let's see if that jives here for a second. So just off to the side, we've already talked about, I'm going to draw a little line here, and I'm going to go off to the side. We already talked about how on a 30, 60, 90 right triangle, that it's all dependent upon the short side. Let's suppose the short side was 1. And we said that the long side is short root 3, so 1 times root 3. And the hypotenuse is 2 times the short side. Let's go see if this jives with what my calculator said. If the sine of an angle is a half, then the angle has to be 30 degrees. Let's go check. What is sine of 30 degrees? Opposite, 1, over hypotenuse, which is 2. See how it all kind of fits in? And your calculator's been programmed with those ratios. So let's say this. Suppose if the cosine of angle, let's say W, equal, and suppose it was as a decimal, 0.732. Then, can I figure out what W is? And the answer is yes. When I want the angle back, I do the inverse key. I do cosine inverse of, that's a little negative, 0.732. So I go to my calculator. Let's bring it back into the view. And I do second cosine 0.732. And my calculator will tell me that we're dealing with about a 43-degree angle. So W would be about, because I'm rounding, 43 degrees. Last up, let's suppose you know the tangent. Suppose you knew the tangent of an angle, let's call it Q, is equal to 1. Let's see if you can figure that out without the calculator. What you're telling me is that opposite over adjacent on some angle is equal to 1, which means opposite and adjacent have to be the same. So let's make an angle where opposite and adjacent are the same length. 5 maybe and 5, or 2 and 2. What's that angle? And you should be going, oh, that's half the square. That angle is a 45-degree angle. Let's go check if our calculator knows that. Back in. All right, if I know the tangent is 1, well then, the angle is found by doing tan inverse of 1. Let's go see if our calculator's smart enough. Second, tan, 45. Oops, sorry. I'm thinking ahead of myself. 1. Enter. Sorry, I forgot to hit second hard enough. Second, tangent, 1. So I'm asking my calculator what angle has a tangent of 1. And it says 45 degrees. All right, so the question often becomes with these, how do I know when I use my sine button or when I use my sine inverse button? When you're looking for the angle measure, you use the inverse. When you're given the angle measure, so suppose it says, what's sine of 42 degrees? Well, then you go sine 42, enter. But if it said the sine of some angle is 0.669, then you do sine inverse to get the angle back. Sorry, I'm hitting a decimal here. This is being finicky. I'm going to just kind of round here. And my calculator will tell me, at about 42, it's going to be a little off because I rounded. But you can kind of see. So you've got your forwards and backwards key, basically. To get the angle back, I'm going to do sine inverse. So I just go to my calculator and I do sine inverse of 0.4848. My calculator will tell me. And let's just round it when we get it. So back onto the screen, I'm looking for the angle measure. So I do sine inverse 0.4848 and enter. My angle is about 29 degrees. So about 29 degrees. Cosine A is 0.5878. What's the angle? Well, it's going to be cosine inverse 0.5878. And you can go do that on your calculator yourself. So next, it says find the measure of this angle. Well, what is this angle? Don't know, but I know a trig ratio. I know I've got opposite and I've got adjacent. So when I'm thinking of my SOHCAHTOA, and I think of which trig ratio has opposite and adjacent, it's tangent. So this is what I do know. I don't know the angle, but I know the tangent of angle question mark is equal to opposite over adjacent. So I'm going to go to my calculator and ask it for the angle. So I have to do tan inverse opposite over adjacent to get the angle back, and it'll tell me. So let's go take a peek. Let's do second tangent. I'm telling my calculator I know the tangent is 27/38, and I want it to tell me the angle measure. And the answer is about 35.4 degrees. So this would be right here about 35.4 degrees. So kind of cool. And there's a lot of applications of this. One that comes to mind right now is like an airplane making a descent, right? So let's suppose it's coming in and it's at an altitude of say 5 and maybe miles, and maybe it wants to hit the runway like 7 miles, and we need to set this angle of depression, we call it. So what would the pilot set that angle to so that it can hit the runway correctly? Well, let's figure that out. I've got a right triangle right here. I know that my runway starts 7 miles away, which is opposite of the angle I'm going to set my thing to. I also know I'm 5 miles up with altitude. So I am dealing with opposite right here, the 7, and adjacent. So I would say the tangent of my angle of depression, let's call it D, would have to equal 7/5. So what should I set my controls to so that I can descend at that? And I'd go second tangent 7/5, and I would figure that I better set that to descend at about a 54-degree angle. Cool. I think it's cool. What's up next here? It's a long video here. All right, so again, I'm looking for this angle measure. Let's go do it. I'm looking for this angle. I have the hypotenuse with regards to that angle and the adjacent side. So I'm going to use cosine because I've got ca going. Cosine question mark is going to equal adjacent over hypotenuse. So to get question mark, I need to go cosine inverse that. So I would like you to stop the video, go do that, and come and show me. Cosine inverse, let's go take a peek. So second cosine and 13/20. And I hit enter, and it tells me that's about a 49.5 degree angle. The next one on the bottom here, am I at a stop sign? Yes, perfect, because this is getting, I don't like the videos to go over 25 minutes. We're at 22 here. So I challenge you right now, again, pause the video, set this up, and you go figure out that angle measure, and then come back and see how you did. So here's my angle in question. I'm going to classify the sides. I've got the hypotenuse, that's always across from the right angle. And then I've got the opposite side of question mark. So I've got O. So when I'm thinking of my SOHCAHTOA, it helps to write that on the top or bottom of everything when you're doing the trig. I have O and H. So I'm going to use the sign. The sign of angle question mark is opposite over hypotenuse. So to get angle question mark, I am going to sine inverse it. So question mark's going to equal, let's bring this back up. We're going to do second sine. It'll give me the angle that has a sine of 40 seconds. And the answer is about a 72-degree angle, which looks pretty good there. Looks like it's about 72 degrees. So let's write, just so you know what you did on here, if you use this on a test, we did sine inverse on our calculators, and we got about 72.2 degrees. And that's the end of it. And I do want you to do all of worksheet 3.1 and 3.2. And that's it for today.